Hello students, welcome back to the ninth video of this playlist. So in this video we will be solving question number 9 from P1 May 2024 paper. So let's see what's the question number 9 is about. So basically question number 9, it's from the concepts and the topics behind question number 9. It has been discussed in chapter number 5 of your P1 textbook, that is straight line graphs. Okay, so in order to be able to solve this question, definitely you should have practiced sufficient questions from P1 chapter number 5 straight line graphs. So let's get started with question number 9. So given that the point A has coordinates 4, 2, okay, the coordinates of point A is given, the point B has coordinates 15, 7, fine. The line L1 passes through A and B. Okay, the line L1 passes through point A and B. So in part A, they are asking to find an equation for line L1, giving you answer in the form Px plus Qy plus r equals to 0, where P, Q, and r are the integers to be found. Okay, so we know the 2 points which lies on the line L1, right? So what we can do, we can use these 2 coordinates to find the gradient at first, right? Because if for finding the equation of line L1 we need the gradient, right? Okay, so for part A, what would be the gradient of line L1? That would be what? y2 minus y1 AB. So 7 minus 2, y2 minus y1 over, so x2 would be the x coordinate of the one with 7, that is 15, y2 minus what? y1 is what? 4. So the gradient is what? 5 over what? 11. So we got the gradient. So now we need the equation of line L1, right? So equation of what? L1. So what would be the equation? We know that the equation would be what? Y minus, we need a point that lies on the line L. So consider point A, that is 4, 2. So y minus y1 would be what? Y minus 2 equals m times what? X minus 4, the x coordinate of point A. So we need this equation in the form of Px plus Qy plus r, right? So multiply both sides by 11, so we'll get 11y minus 22 equals to what? 5x minus 20. So take all of the terms in the same side, so you will get 5x negative what? 11y. Okay, then minus 20 plus 22, that is plus 2 equals to 0. So this is the equation of line L1. So here P equals to 5, Q equals to what? Negative 11, okay, and R, it's equals to what? R equals to 2. Done. Next, part B. What they have asked in part B, the line L2 passes through A and is parallel to the x-axis. Okay, it passes through A and is parallel to the x-axis. So if a line is parallel to the x-axis, then what would be its gradient? X-axis is basically what? Horizontal. So it would be like that, horizontal, right? It would be a horizontal line. Okay, it would be like this. Okay, a parallel line to the x-axis. So this is the line L2. So what's the scenario? The point C lies on L2. On line L2 there is a point C lies, so that the length for B to C, BC, okay, the length of BC is 5 square root of 5. Okay, so let us consider the equation of line L1. L1 is what? The gradient is 5 over 11. and the y-intercept is basically, if you put x equals to 0, you will be getting y equals to 2/11. Okay, this is positive. Okay, so I'm considering the y-intercept to sketch the line L1, so it would be like this. Basically it would be like this. Okay, just a sketch. This is line L1 for your understanding. This is line L1 and this is line L2 that is parallel to x-axis. So point B lies on L1, right? Its coordinates is what? 15,7. So 15,7, you can consider it here. 15,7. Okay, this is point B. So the length of B to C, okay, on line L2 the point C lies. Okay, so the distance from B to C, it's what? 5 square root of 5. So we need to find the possible pairs of coordinates of the point C. Okay, fine. So since the line L2 passes through point A, that means point A is the point of intersection between the line L1 and what? L2, right? Because A through point A, line L1 is also passing through. So that means this is the common point between line L1 and L2. So point A is the point of intersection between the line L1 and L2. So equation of line L2 would be y equals to something. Since it is a horizontal straight line, so that would be what? Y equals to something. So equation of line L2. What would be the equation of line L2? Equation of what? L2. It is what? Y equals to the y coordinate of point A, there is nothing but 2. So y equals to 2. Okay, we got the equation of line L2. Now we need the possible coordinates of point C. So the distance between B to C is given. So what's the equation for distance? Distance is square root of what? y2 minus y1 whole squared, right? So point C, since it lies on the line L2, so its coordinates would be C. Point C will have, consider the x coordinate as A, just this is a variable, and the y coordinate would be what? 2, since it lies on line L2. So A and 2. So BC, distance between BC, this is what? y2 minus y1. So 2 minus the y coordinate of point B is what? 7. So 2 minus 7 whole squared plus what? A minus 15, right? A minus 15 whole squared, this is equals to how much? 5 square root of 5. If I'm not wrong, this is 5 square root of 5, exactly 5 square root of 5. Now square both sides, so we'll get what? A negative 5 whole square, that is 25, plus A minus 15 whole squared, this is equals to what? 25 times 5, that is 125. Okay, next is A minus 15 whole squared, this is equals to what? 125 minus 25, that is 100. So if you do the square root, what you will get? You will get A minus 15, it is equals to what? Plus minus 10, isn't it? Plus minus 10. Fine. So either you will get the value for A is what? Plus 10 plus 15, that is 25, or A equals to what? Minus 10 plus 15, that is what? Minus 10 plus 15, that is 5. Okay, that is 5. Done. So we got the two possible positions for C. That is what? Either C is what? 25, 2, x is 25, y is 2, or what? C is what? 5 and what? 2. This is the two possible coordinates for point C. That's it. Next, part C. For part C, they are asking hence. That means hence, since it says hence, that means we need to use our answer from part B. find the minimum possible area of triangle what? ABC. We need to find out the minimum possible area between ABC. Okay, the figure is very important here for understanding that concept. ABC, right? So ABC is basically this one. Okay, so another possible positions we got there, it's basically it's just an example, a sketch, not an example, it's just a sketch. So 25.2 and 5.2 both are positive. So C was supposed to be in the positive x-axis. It would be better if it is, okay, C should be in the positive x-axis, right? Let me delete that. Since C should be in the positive x-axis, let us consider it here. Okay, this is one possible position for C, and another one is 25.2. So this is another possible position. Okay, now we need to find out the minimum possible what? Minimum possible area. So which one will give us the minimum possible area? So in order to find that, we need to consider the two possible positions for C. One is 5.2, the other one is what? The other one is 25.2. So which area will be the smallest? We need to find it out, right? We need to find it out using half times base times height. So for this case, at first you need to find out what? The distance. Which distance? So we need the distance between A, C, the two possible positions for C. Okay, we can't use any area of triangle formula. Half of base times height. Okay, let's have a sketch, clear sketch of this scenario. Since we know the 2 points now with the coordinates like of the two possible positions of C, so depending on that we can have a clear image now for the sketch. So let me draw it beside it. Consider here. So the line L2, it is parallel to the x-axis, so this is this one, okay, and line L1, it's basically, how is it passing through? Line L1, it has a positive gradient, so it will pass like this, right? This is line L1. Okay, now the concept is point A is 4.2. okay, this point is the point of intersection, what I said, this is the point of intersection A, this is what? 4.2. this is point A, 4.2, and then point B is what? 15.7, 15 and then 7. Okay, 15.7. Consider this is the point 15.7. this is point B, that is 15.7. next, the two possible positions of point C, one is 15.2, right? Sorry, one is 25.2. yes, 25.2 and 5.2 both are positive. So 25.2, so 25.2, that means it will be more right of B. This is one, which is 25.2, and the other one is what? 5.2. 5, that means it should be on the right side of A. And the one is what? Here, 5.2. So it would be here. This is what? 5.2. This is C, or it is what? C, 5.2. Okay. Now which one would give us the smallest area? ABC, right? This is 1 and this is BC again. Okay, so we need the minimum possible area. So which one will give the minimum possible area? Definitely the smaller one. You can see, you can easily understand from the sketch now, since it is clear now. The smaller one will give us the smallest, that is minimum area. So which one? Let me mark it in this sketch. This is this region, this triangle will give us the minimum area. So let's find out the area, right? We understood. So this is between A, that is 4.2, C, that is 5.2, and B, that is 15.7. So we know the area of triangle is what? Half times base times height. Okay, that's an important thing. Most of the students will get confused, like how can you find out the area of the triangle, right? Since it's not right angled or it's not asymmetrical. So basically we know the area of triangle is half times base times height. Okay, so you can use this formula to find out the area of the triangle. Remember, half times base times height, it's not like that. It like this equation, this formula, it's just can be used for right angle triangle. It's not like that. It can be used with any of the triangles if you know the base and if you know the height of the vertex. Okay, so here the vertex is what? The maximum point is B. So its height is, from the base, its height is what? 7, right? The y coordinate. So 7, it's from the x-axis, it is 7. So from the base, this is 2. So the base, from base, the height is what? 7 minus 2, that is 5, right? So the area, what would be the area? Half times, we need the minimum possible area. So for part C, minimum area, that is what? Half times, what was the height we got? That is 7 minus 2, that is height, and base is what? What would be the base? Base is basically 5 minus 4, isn't it? 5 minus what? 5 minus 4. Okay, so 5 minus 4 is what? 5 minus 4 is 1. So 7 minus 2, that is what? 5. 7 minus 2, that is 5. So 5 over 2 unit squared. This is the minimum possible area. So like previously, since the positions of the two positions for the point C was unknown, that's why I wrote, the sketch was not perfect, but when I wrote the perfect sketch, it is visible that which area is the minimum or the smallest. So for this type of questions, definitely the sketch is a very important thing. So for this type of questions, for your understanding, try to draw a perfect sketch as much as possible. That will help a lot for your correct solution. So that was all about question number 9 from May 2024 P1 paper. That's it.